Hello everybody, now we're going to be talking about our Calc House. This is basically the tool that we use to determine what our derivatives and double derivatives will look like after looking at our parent function. So our parent function is going to be, here you want to go right here, it's going to be looking like this. It's at the top, then our derivative is going to be up or down here below it, and then our double derivative is going to be all the way at the bottom. So we start off is by marking our parent function's sort of components. So we have plus, minus, plus, up, down, up, or up to the right, down to the right, up to the right, and then open upwards, open downwards, and open upwards once again. And then what we're going to do with our derivative is we're going to write the exact same thing, but 3 spaces to the right. So we have a plus, minus, plus, up to the right, down to the right, and up to the right. So we're already going to go ahead and talk about what this basically means. So what this means is that when our parent function has a slope that goes upwards, then our derivative, it's going to be above the x-axis. So it's going to be on the positive side of the x-axis. And then when our parent function has a slope that goes downwards, that's negative, then our parent or derivative will be on the negative side of the x-axis. And it's the same pretty much with the double derivative. We will have plus, minus, plus. Now it's going to be 6 places to the right, because now again, if we are looking at our derivative as our sort of parent function, then we'll see that when the derivative has a positive slope, then the double derivative will be on the top side of the x-axis, and again, just the other way around, when it's pointing downwards, will be on the negative side of the x-axis. Now when we look at our parent function and we have a sort of parabola that's pointing upwards, when it's open upwards, then we're going to see that our derivative will then have a slope that is positive, and that the double derivative will then be on the positive side of the x-axis. And then when it is open downwards in the parent function, we'll see that the derivative will be having a downward slope that is negative, and then the double derivative will also then be below the x-axis on the negative side. So that's the way you can interpret the Calc House and how you can sort of interpret graphs as you look at them. So now we have our Calc House done, but it's time to visualize it. So basically what we do when we try to visualize this stuff is sort of look in between these little rooms of our house. Let's start off with when it's opening upwards to when it's opening downwards. How we can visualize this simply is that it's opening upwards here and then transitions into opening downwards. So here's the upwards part, here's the downwards part. But there's also a point in the middle. That would be our point of inflection. And we can sort of look at it down here, what it would mean. So it would be points like right here where it goes from up to down, and then it goes to down to up. So that's sort of right there. And then down to up, sort of right there. The points of inflection are basically just the midpoints between these specific parts on your graph. Obviously, I'm just estimating, but there are specific points of inflection. Then we'll look at the local and, so basically maxima, extrema, and then minimum extrema. So the local extrema you can find, again, by looking at the midpoints in between your rooms, mainly where it goes from a positive slope to a negative slope. So we'll just go over here again. If you want to visualize this simply again, this is having a positive slope and then it goes into having a negative slope. But then there's a point in the middle, and that will be our extrema. Here it's the same thing. So we're going a negative slope to a positive slope. And then there's a local extrema. So just simply visualizing it here on an actual graph, you can see that we are going upwards here, having a positive slope, to a downwards slope. So in the middle here, we have our extrema. We continue with a downward slope and transition to an upward slope, which would give us an extrema somewhere around here. That's how you can sort of visualize where all your different parts of a graph are, with points of inflection, local extrema, and then all the other stuff in the Calc House using the components of the Calc House.